When we're talking about balanced equations, it's first important to identify what a chemical reaction is made up from. We've got things that go in, which are known as reactants. A chemical reaction will take place and a new substance will be formed, which will come out, and that is known as a product. So for example, if you were baking in your kitchen, you could have some flour, some eggs, and some chocolate. You would bake that in an oven in a chemical reaction, and a new substance would be formed. It would be your chocolate cake. Everything that you put into the oven came out, just in a different form. Remember that the first law of thermodynamics is that you cannot create or destroy matter, you can only change its form. Our reaction is balanced. What went in came out. In an equation, on the left-hand side, we have reactants which go in. On the right-hand side, we have products that come out. When a chemical reaction takes place, a new substance is always formed. What goes in must come out. Let's take this as an example. If we've got magnesium, which has the chemical symbol Mg, we're going to pop a box around that, and we react it with oxygen, which has the chemical symbol O2, and we pop a box around that too. What we can do is not only representing that using the chemical symbols, but we can actually use pictures to represent what's happening. So here I've got a blue circle which represents the magnesium atom, Mg, and I have got oxygen, which is a diatomic molecule. So I've got two pink circles which are chemically joined together, which represent a molecule of oxygen. When the magnesium and oxygen react, they form a new product. The product's known as magnesium oxide. It ends in "ide", the D stands for double, which means it's only made up of two elements. The chemical formula for that is MgO, and we'll keep that in a box. If we were to represent the magnesium oxide via a picture, we would have one magnesium atom, which is represented by a blue circle, chemically joined to an oxygen atom, which is represented by the pink circle. What we can see from the pictures is that on the left hand side we have two oxygen atoms, and on the right hand side we've only got one. That's the pink circle. This means that the chemical reaction is not balanced. As a result, we have to add another magnesium oxide to the right hand side of the equation. That's so that we've got the same number of oxygen atoms on either side. At this stage, we add a 2 in front of the magnesium oxide in the chemical equation. That tells us that we have 2 magnesium oxides. However, there's now another issue. On the right hand side, we now have 2 magnesium atoms, and on the left hand side, we only have 1. So to balance this out, we need to add another magnesium atom to the left hand side. We put a 2 in front of the magnesium on the chemical equation. Now what we can see from the pictures is that we have 2 magnesium atoms, 2 oxygen atoms on either side of the equation, which means that the equation is now balanced. When we balance equations for compounds that end in "ide", we can either use the pictorial method or the box method. The box method is used for the intermediate and advanced balanced equations in the next couple of videos, and there's a couple of rules that we have to follow when we're doing the box method. This will be much easier if you can get your head around this for exam past paper questions. So the first rule is that you always need to put boxes around the formula that you've been given in the equation. You cannot put any numbers inside those boxes. The next step is to write down your elements. I want you to think about Santa Claus. He says, ho, ho, ho. You want to do all other elements, then hydrogen and oxygen last. Rule number 3 is that when you are putting your multiples, you have to put it before the box. Again, look at rule number 1. Do not put any numbers in the boxes. And rule number 4 is that Santa always checks his list twice. So you have to go back up to your list and check that all of your elements are balanced. So here we are given the same equation as before, but I'm going to show you how to use the box method. So we've been given our equation, Mg plus O2 goes to MgO. Step number 1, we have to put boxes around each of the entities that are given in the equation. Remember, Santa says ho ho ho, so we need to do all elements, then hydrogen and oxygen last. So we're going to write our shopping list. We've got Mg and O, and we're going to mirror that on the other side, Mg and O. On the left hand side, how many magnesiums do we have? We have 1. And how many oxygens do we have? We have 2, because of the small 2 that's after the chemical symbol for oxygen. On the right hand side, how many magnesiums do we have? We only have 1. There's no number directly after the chemical symbol for magnesium. And how many oxygens do we have? We have 1. We're going to start at the top of our shopping list. On the left hand side, we've got 1 magnesium. On the right hand side, we've got 1 magnesium. They balance, so we tick them off. On the left hand side, how many oxygens do we have? We have 2. On the right hand side, how many do we have? We only have 1. What do we do to 1 to get to 2? We multiply by 2. So we put a big 2 in front of the magnesium oxide. Remember, you do not put any numbers inside the box. That means that we now have 2 magnesiums and 2 oxygens. The oxygens balance, so we can tick them off. Just like Santa does and checks his list twice, we go back up to the top. How many magnesiums do we have on the left? We only have 1. And how many do we have on the right now? We have 2. These don't balance. What do we do to 1 to get to 2? We multiply by 2. We tick them off. How many oxygens do we have on the left? We still have 2. And on the right, we have 2. This is our balanced equation. Here's a second example of a balanced equation using the pictorial methods. We have hydrogen, which has the chemical formula H2, and we'll keep that in a box. And it reacts with oxygen, which has the chemical formula O2, and we'll keep that in a box. If we were to use pictures to represent that, 2 hydrogen atoms, which are chemically joined together, are represented by the blue circles, and an oxygen molecule, which is represented by the 2 pink circles. When they react together, they form hydrogen oxide. The compound ends in "ide", the D stands for double, which means it's made up of 2 elements. The more common name for this is water, which has the formula H2O. Again, we'll keep that in a box. If we were to represent that by a picture, we would have 1 pink circle with 2 blue circles, chemically joined together, H2O. What we can see from the pictures is that the equation is not balanced. We have equal numbers of hydrogen atoms on both sides of the equations, but we've got unequal numbers of oxygen atoms. So to balance this out, we have to add another water molecule to the right hand side. So now that we have got 2 water molecules, we put a big 2 in front of the chemical formula, 2H2O. The issue that we've got now is, although we have balanced the oxygen atom, so we now have 2 on either side, we now have an unequal number of hydrogen atoms. On the left hand side, we only have 2, and on the right hand side, we have 4. To balance this out, we would add in another hydrogen molecule. Because we've done this, we can add a big number 2 in front of the H2 in the chemical equation. We now have a total of 4 hydrogen atoms on the left, 4 hydrogen atoms on the right, 2 oxygen atoms on the left, and 2 oxygen atoms on the right. the equation is balanced. I'm now going to show you how to use the box method for the exact same equation. The first thing that we have to make sure that we do is that we've got boxes around the entities in the equation. Remember, Santa says ho ho ho. So we do all elements and then hydrogen and oxygen last. So we've got a hydrogen, which is represented by the symbol H, and then we've got an oxygen, which is O. We mimic that on the other side. How many hydrogens do we have on the left? We've got 2. How many oxygens do we have? We have 2. On the right hand side of the equation, how many hydrogens have we got? We've got 2. And how many oxygens do we have? We've got 1. We start at the top of our shopping list. How many hydrogens do we have on the left? We have 2. On the right we have 2. Those balance, so we can tick them off. On the left hand side, how many oxygen atoms do we have? We have 2. On the right, we only have 1. These don't balance. What do you do to 1 to get to 2? You multiply by 2. So we put a big 2 in front of the H2O. Remember, we don't put any numbers inside the box. We've got 2 hydrogen atoms inside the box multiplied by the 2 outside the box. 2 times 2 is 4. We've got 1 oxygen atom inside the box multiplied by the 2 outside the box, and that means that we've got 2. Our oxygen atoms balance, so we can tick them off. Remember, we have to check our shopping list twice, so we go back up to the top. How many hydrogens do we have on the left? We have 2. How many do we have on the right? We now have 4. What do we do to 2 to get to 4? We multiply by 2. So we put a big 2 in front of the H2. 2 hydrogens inside the box multiplied by the 2 outside the box gives us 4. They balance, so we can tick them off, and our oxygens are still balanced. This is our balanced equation. This example is a little bit trickier. We are going to be using 3 different types of element instead of 2. So if we were to have magnesium, which is represented by the chemical symbol Mg, and again we're going to keep a box around that, and react it with hydrochloric acid, which has the formula HCl, and again we're going to keep a box around that. We can represent that via pictures. The magnesium is a blue circle, and the hydrochloric acid is one pink chemically joined to a green chlorine. When they react together, they form 2 products. They produce magnesium chloride. Remember, it ends in "ide", which means it only has 2 elements. Using the SVSDF method in the previous videos, the formula for magnesium chloride is MgCl2. So we'll pop a box around that, and we can represent that via the picture with 1 blue circle combined with 2 green circles, MgCl2. It also produces hydrogen gas, which has the formula H2. We'll keep a box around that, represented by 2 pink circles chemically joined together. What we can see via the pictures is that the magnesiums balance on either side. However, the hydrogens and the chlorines do not. On the left hand side, we've only got 1 hydrogen atom, and on the right hand side, we have got 2. To balance that out, we can add another hydrogen chloride to the left hand side, or the reactant side of the equation. We now have 2 hydrogen atoms and 2 chlorine atoms. We put a big 2 in front of the formula for the HCl. What we can see is the equation is now balanced. So this is the last example showing you how to do the box method. The first thing that we have to make sure that we do is, from our equation, we put a box around each of the entities. Remember, ho ho ho, we do all other elements, then hydrogen and oxygen last. So we have magnesium, Mg, chlorine, Cl, hydrogen, H. We mimic that on the other side. How many magnesiums do we have on the left? We have 1. How many chlorines? 1. How many hydrogens? 1. On the right hand side, How many magnesiums do we have? We have 1. Chlorines, we have 2. And hydrogens, we have 2. We start at the top of our shopping list. Magnesiums on the left, we have 1. Magnesiums on the right, we have 1. They balance, so we can tick them off. How many chlorines do we have on the left? We have 1. How many chlorines do we have on the right? We have 2. What do we do to 1 to get to 2? We multiply by 2. So we put a big 2 in front of the HCl. How many hydrogens do we have inside the box? We have 1. 1 times 2 outside the box gives us 2. How many chlorines do we have inside the box? We have 1. 1 times 2 is 2. Our chlorines balance, so we can tick them off. How many hydrogens do we have on the left? We have 2. How many do we have on the right? We have 2. They balance, so we can tick them off. This is our fully completed balanced equation. Here are 3 examples of equations that I would like you to have a go at balancing. You can either use the pictorial method or the box method, but the past paper questions which are going to follow this are going to be using the box method, so try your best to wrap your heads around that idea. So if you want to pause the video, as soon as you're ready you can resume and the answers will pop up on the screen. This first past paper question is from the Intermediate 2 2015 past paper, written 5B Part 1. The second stage involves reacting the titanium chloride with sodium in an atmosphere of argon gas. Balance this equation. The first step, we want to put boxes around each of the entities given in the balanced equation. Remember, Santa says ho ho ho. So we do all elements, then hydrogen and oxygen last. So we have titanium, Ti, sodium, Na, and chlorine, Cl. We mimic that on the other side. How many titaniums do we have on the left? We have 1. How many sodiums do we have? We have 1. And how many chlorines do we have? We have 4. On the right hand side, how many titaniums do we have? We have 1. How many sodiums? 1. And how many chlorines? 1. We start our shopping list at the top and check that they are balanced. On the left hand side we've got 1 titanium. On the right hand side we've also got 1 titanium. We can tick them off. They balance. How many sodiums do we have on the left? We have 1. How many do we have on the right? We have 1. So we can tick them off. How many chlorines do we have on the left? We have 4. How many do we have on the right? We have 1. This doesn't balance. What do we do to 1 to get to 4? We multiply by 4. So we put a big 4 in front of the sodium chloride. How many sodium atoms do we now have? We've got 1 inside the box multiplied by 4 outside the box, which means we have 4 sodiums and 4 chlorines. The chlorines balance, we can tick them off. Remember, we have to double check our list. Titaniums, 1, 1. Those are still balanced. Sodiums, we've got 1 on the left and 4 on the right. What do we do to 1? To get to 4, we multiply by 4. So we put a big 4 in front of the sodium. This means that our equation is balanced. This question's from the National 5 2018, written 10A. Ammonia is made industrially by reacting nitrogen with hydrogen. The equation for the reaction is shown below. Balance the equation above. First step is to put boxes around the entities. We then have to write our shopping lists. Remember, ho ho ho. All other elements, then hydrogen and oxygen last. So we've got an N for nitrogen and a H for hydrogen. We mimic that on the other side. How many nitrogens do we have on the left? Well, there's a small 2 after the chemical symbol, so we have 2. How many hydrogens do we have? We have 2. On the right hand side, how many nitrogens do we have? We have 1, because there's no number directly after the chemical symbol. And how many hydrogens do we have? We have 3. So we check our shopping list. Nitrogen, we've got 2 on the left, 1 on the right. That doesn't balance, so we have to put a 2 in front of the NH3. Remember, we don't put a number inside the box. 2 times 1 is 2. How many hydrogens have we got inside the box? We've got 3. But how many numbers have we got outside the box? That's 2. 3 times 2 is 6. So we've now got 6 hydrogens. Nitrogen's balanced, so we can tick them off. On the left-hand side, how many hydrogens have we got? We've got 2. How many hydrogens have we got on the right-hand side? We've got 6. What do you do to 2 to get to 6? You multiply by 3, so we put a big 3 in front of the hydrogen. We double check that we have got the same number. We do, so we tick them off. Double check our shopping list. 2 nitrogens, 2 nitrogens, 6 hydrogens, 6 hydrogens. The equation is balanced. This past paper question is from the Intermediate 2 2010 multiple choice 8. So the first step, we have to put boxes around the entities that are given in the equation. Remember, we have to do ho, 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 all other elements, then hydrogen and oxygen last. So we've got aluminium, which is represented by Al, and we've got bromine, which is Br. We mimic that on the other side. How many aluminiums do we have on the left? We've got 1. How many bromines do we have? We have 2. On the right hand side of the equation, how many aluminiums have we got? We've got 1. And how many bromines do we have? We've got 3. We start our shopping list at the top to see if we have got them balanced. How many aluminiums do we have on the left? We've got 1. On the right, we've got 1. They balance, so we can tick them off. How many bromines do we have on the left? We have 2. And how many bromines do we have on the right? We have 3. These don't balance. How do we balance out numbers which cannot be multiplied by 2? Well, what we have to do is we have to cross multiply. So the aluminium bromide, so that's the product, the AlBr3, we put a big 2 in front of the box. We've got 1 aluminium inside the box multiplied by 2 outside the box. 1 times 2 is 2. How many bromines do we have inside the box? We've got 3. 3 times 2 is 6. To balance out the bromines on the left-hand side of the equation, well, what do we do to 2 to get to 6? We multiply by 3. So we put a big 3 in front of the Br2. 3 times 2 is 6. The bromines balance, so we can tick them off. We need to double check our shopping list. How many aluminiums do we have on the left? We've got 1. How many aluminiums do we have on the right? We've got 2. Those don't balance. What do I need to do to 1 to get to 2? We multiply by 2. So we put a big 2 in front of the box, in front of the aluminium. 2 times 1 is 2. Our aluminiums balance, so we can tick them off. We double check our bromines, they still balance, so we can tick them off. So the correct answer to this multiple choice past paper question is B.